5.6 homework, I'm going to work problems 2, 3, and 5 based on some information that one of the students gave me. So if you are having problems with any of the other ones, you can ask me about them. So problem number 2, a rectangle has its base on the x-axis and its upper corners on the parabola y equals 12 minus x squared. So I'm going to do a little sketch of this. It's always great to have a picture. I don't even know if I could even solve this problem without a picture. This is my y equals 12 minus x squared. So it's a downward facing parabola that's been shifted up 12 units. And they're talking about a rectangle that's base is on the x-axis, but it's like inscribed in that. So a rectangle has its base on the x-axis and its two upper corners on the parabola. Okay, so there's my upper corners on the parabola. Here's my base on the x-axis right here. We're going to take one of these points, and I think the one in the first quadrant is the easiest. It is an xy point, but since it is on the parabola y equals 12 minus x squared, we're going to call it x comma 12 minus x squared. Okay, so that we don't have two unknowns. So that point is going to be x comma 12 minus x squared. So now, they want the largest possible area of the rectangle. I know that the area of this rectangle is length times width, okay? And this is what I'm going to maximize. So I'm going to be maximizing the area of that rectangle. When I think about this point right here, I think, oh, I'm starting at 0, 0, and I'm going x over here, and I'm going y up to here, okay? I also know that this is symmetrical, so this is also going to be the same x, okay? So I actually have a rectangle that has a base that is 2x and a height that is y, but my y I already said was 12 minus x squared. So I'm not even going to worry about y, I'm just going to make that 12 minus x squared. So if I needed the area of that, it's going to be 2x times 12 minus x squared. This is what we are maximizing. And I went ahead and distributed my 2x so that I have a nice polynomial to take the derivative of. Because when I want to maximize something, I want to find that critical point, and so I'm going to take the derivative, set it equal to 0. So my derivative is 24 minus 6x squared. I'm going to set that equal to 0. That gives me my 6x squared equals 24, my x squared equals 4, my x equals plus or minus 2. And so now I look and I say, well, the negative 2 makes no sense, right? Because we have a distance. So positive 2 is really the only one that I'm going to focus on. And then I just want to make sure that that's a maximum. So I'm going to put a 1 into my derivative, and 24 minus 6 is a positive 18. I'm going to put a 3 in my derivative, and 24 minus 6 times 9 is going to be a negative value. So I do know that by the first derivative test, I do have a maximum. And so it says, what is the largest possible area? Well, to find the largest possible area, I have to take 2 times 2, right? Because that's going to be my 2x, my length, and then times 12 minus 2 squared. So this is going to be 4 times 8. So my maximum area for that rectangle is going to be 32, and they really didn't give us any units, so I'm going to say 32 units squared. And typically when it's a word problem, I go ahead and just also for my own self, write it out that the largest possible area of the rectangle is 32 square units when x equals 2. Okay? So now on number 3. The owner of an orange grove estimates that if 24 trees are planted per acre, then each mature tree will yield 600 oranges per year. And then it says for each additional tree planted per acre, the number of oranges produced by each tree decrease by 12 per year. How many trees should be planted per acre to obtain the most oranges per year? So think about this as if you plant 24 trees per acre and each one gives you 600 oranges. That means that you're going to have a total of 14,400 oranges per acre each year, right? Per year. Because 24 trees are planted per acre. Each mature tree will yield 600 oranges per year. Okay? So 14,400 oranges per acre every year. And so now it said for each additional tree planted, they already know that 24 trees is going to give them 600 oranges. But if they plant more, it causes those trees to decrease by 12 oranges per year. But what is that happy medium? Can I add some trees, and even though the other ones reduce by 12 per year, it might end up giving me a greater amount? So how many trees should be planted per acre to obtain the most oranges per year? So we're going to let x equal the number of trees planted per acre above 24 trees. So that extra set number of trees that is more than 24. And if I do that, then my total number of oranges is going to be 24 plus x times 600 minus 12x, because every single one of those x trees, it's going to cause the other ones to reduce by 12, the total number of oranges. So instead of just 24 times 600, when you're putting more trees out there per acre, you've got to now calculate 24 plus x times 600 minus 12x, because the number of oranges produced by each tree decreased by 12 per year for each additional tree planted per acre. So this is going to be your new total number of oranges equation. And if we want to maximize the total number of oranges per year, we're going to take the derivative of this. So if I take 24 times 600, I'm going to get that 14,400. And then I've got my plus 600x. I've got my minus 288x. And I've got my minus 12x squared. So I'm going to just add my like terms. 14,400 plus 312x minus 12x squared. Now I'm going to take the derivative. And I get 312 minus 24x. set that equal to 0. Okay, and I get x equals 13. I do just want to make sure that that is a maximum. So I put a 12 in, and I end up getting a positive value. I put a 14 in, and I get a negative value. So that does verify that I have a max using the first derivative test. So now, remember, this is the number of trees above 24. And they're asking us how many trees should be planted per acre to obtain the most oranges per year. So to find that final answer, I'm going to have to take 24 plus 13. 37 trees need to be planted per acre to obtain the most number of oranges per year. So 37 trees per acre. So I said to maximize the number of oranges each year, 37 trees should be planted per acre. Okay, and then the other one that someone asked about was number 5. Find the dimensions of the rectangle with a maximum area inscribed in a semicircle with a radius of 8 inches. So the rectangle is inscribed in a semicircle with a radius of 8. So I think the best idea for this one is to just do one of these semicircles. Remember that if you have a circle with a radius of 8, this is going to be x squared plus y squared equals 64. And then remember how you can't put that in your calculator. You have to put it, because if you wanted to solve for y to try and put the whole circle in your calculator, you had to subtract x squared from both sides and take the square root of both sides, and you had plus or minus the square root of 64 minus x squared. And the top part of your circle is your positive one, and then if you wanted to put the bottom one on, that's your negative, because you can't, a circle is not a function. It would have failed the vertical line test, but if you do them separately, you can cheat your calculator kind of. Well, this comes in handy here because we're only looking at the top part of it because it's a semicircle. So this function is y equals the square root of 64 minus x squared. So all the points that are on this function satisfy this equation. And they said that your rectangle was inscribed like this. And I know my picture doesn't look like it, but this is symmetrical. That means that, we're going to end up picking a point here, and it's going to be an xy point on your function. And so this from here to here is going to be x, and from here to here is going to be y, but we know what y is. We're going to end up, calling this point x comma square root of 64 minus x squared, because that's what that is. But when I say it's symmetrical, this right here is also x. Even though my picture doesn't make it look like that because I goofed and it's not perfect, but hopefully you can see that. You know that those circles that are centered at 0, 0 are, symmetrical like that. So we're trying to maximize the area of the rectangle. So the area of the rectangle is length times width. And so you can see that this rectangle is 2x by y, but your y is square root of 64 minus x squared. So if I wanted to find the area, I'm going to take 2x times the square root of 64 minus x squared. And so this is the thing that I want to maximize, because I want to maximize area. So this is going to be what I take the derivative of. And notice that when you take the derivative of this, you have to use the product rule. So you've got your first times the derivative of the second. So I would have to bring my 1/2 down, times 64 minus x squared to the negative 1/2, times the derivative of 64 minus x squared, which is negative 2x, and then plus the second, which is square root of 64 minus x squared, times the derivative of the first. The derivative of 2x is 2. So I'm just squeezing that in. So let's move it over here where I have space. I want you to notice that, and I'm going to show you here, this whole thing is one term. So if I want, to get rid of this 2 right down here, because let's say I just don't want that in the denominator, I can get rid of it with this, because that's multiplication, and this is also multiplication. Or I could have gotten rid of it with this 2. Either one, but you can't do both, but you have to do one or the other. But that is this times this times this times this. So since that's all multiplication, you can, get rid of that 2 like that pretty easily. So let's go ahead and continue here. We end up with this x times negative 2x. So this is going to be negative 2x squared. And I'm going to bring my square root of 64 minus x squared down to the denominator. And then we've got plus 2 times the square root of 64 minus x squared. That has a denominator of 1. So you can see that I need to add these two. And when I do that, I'm thinking, okay, my common denominator is the square root of 64 minus x squared. So I need to multiply the second term by the square root of 64 minus x squared over the square root of 64 minus x squared. And so that's going to become negative 2x squared plus 2 times 64 minus x squared. And so we've got negative 2x squared plus 128 minus 2x squared over the square root of 64 minus x squared. That gives us negative 4x squared plus 128 over the square root of 64 minus x squared. Okay, so that is our derivative. And remember, when we set it equal to 0, we only need to worry about technically, to find your minimum, or maximum, you'd either set the numerator equal to 0 to find where it's 0, and the denominator equal to 0 to find where it's undefined. But we know that it's not going to be 8, so what makes it undefined would be 8, because 64 minus 8 squared would give you 0. But I'm not going to have a rectangle that's all the way over here. That wouldn't make any sense, okay? So we don't even need to worry about the denominator being set equal to 0, because it doesn't make any sense for this problem. So sometimes problems just, you have to make sense of it and try and figure out, would that even make sense for this to even be true? Okay, so I've been going on setting my numerator equal to 0. I, moved my negative 4x squared over. It became positive 4x squared equals 128 divided by 4. Got x squared equals 32. Took the square root of both sides. X equals, the square root of 16 times the square root of 2 would be x equals 4 root 2. So, and I could do plus or minus, but I know that I'm going to throw the minus out. So I'm not even going to worry about doing plus or minus. This is my critical point. You can, just verify that 4 root 2 is a maximum by looking at, something that's less than 4 root 2 putting that in, and you should get a positive. And if you put this in, you put negative. This is a maximum. And that means that you need to go 4 root 2 over here, and then up square root of 64 minus 4 root 2 squared. So on this problem, it's asking find the dimensions of the rectangle. They want the length and the width of the rectangle. So even when I got my answer of x equals 4 root 2, that's not the width or the length of my rectangle, because my rectangle is 2x times, by the square root of 64 minus x squared. So we're going to say, well, to find the length, we're going to take 2 times 4 root 2. So that's going to be 8 root 2. That's the length of the rectangle. To find the width of the rectangle, we're going to take the square root of 64 minus 4 root 2 squared. So that's the square root of 64 minus, this would be 16 times 2. Square root of 64 minus 32. That's the square root of 32, which we said was the square root of 16, which is 4 root 2. So that's your width. So the dimensions of this rectangle are going to be 8 root 2 by 4 root 2. And that was what it was asking. They were asking for the dimensions of the rectangle. 8 root 2 units by 4 root 2 units. Or no, it was inches, sorry. Or was it inches? Yeah, 8 inches. So that was 8 root 2 inches by 4 root 2 inches. Sorry about that. Okay, well, that's the 3 that people had asked me about. So maybe those